We've discussed adding and subtracting functions, as well as multiplying and dividing functions, and now we're going to take a look at the composition of functions. And when we compose functions, we're substituting, let's say for instance, commonly we would say that this is f of g of x, g of f of x, the fog and the goth. But what we're actually doing is we're taking, let's say in f of g, we're taking the function g of x and substituting it in for x in f of x. And then once we do g of f, we're doing the same thing, except we're going to take f of x and substitute it in for x in g of x. And then we're going to take a look at the domain and the range. So here it says, for each pair of functions, find f of g of x, the fog of x, and g of f of x, the goth of x, if they exist. State the domain and range for each composed function. And then we're given two functions, f of x equals x squared plus 2, and g of x equals x minus 6. So let's first then work on f of g. So we got f of g of x. And what we're going to do is we're going to substitute in g of x, which in this case is x minus 6, for x in f of x. And so once we do that, then we would have x minus 6 squared plus 2. Well, I need a little room to work because I got to square x minus 6. So let's go over here. I'm going to go x minus 6 times x minus 6. Well, x times x is x squared. X times negative 6 is negative 6x. Negative 6 times x is negative 6x. And negative 6 times negative 6 is positive 36. So we have squared x minus x. And now we're just going to enter that, and we'll do a little bit of combining of like terms. So negative 6 of x then is negative 12x plus 36 plus 2. And let's finish combining the like terms. And so f of g of x equals x squared minus 12x plus 38. All right, so on the next slide, I have graphed f of g, x squared minus 12x plus 38, and we're going to take a look and describe the domain and the range. So here we see the graph of this, f of g of x. Let's see, what was that? F of g of x equaled x squared minus 12x plus 38. And, well, my domain, I don't really have any restrictions. I look at that function equation. I don't have any restrictions in the domain of that. What are my two primary things that can restrict the domain? Taking the square root of a negative number or dividing by 0. So my domain is equal to all real numbers. But f of g is a quadratic. And we should have already learned that we'll see some restrictions on the domain if we got a quadratic function. And when y, looks like we bottom out right here, where y is equal to 2. And so then our range is going to be y such that y is greater than or equal to 2. And that would define our range. We see a bottoming out in our parabola where y is equal to 2. Now let's go do g of f and g of f, the goth, and see what happens. All right, so this time we're going to do g of f. I'm going to substitute in f of x for x in g of x. So we've got g of f of x, and that is going to equal x squared plus 2, there's my f of x being substituted for x, then minus 6. And we get to combine like terms, and so we got x squared minus 4 is g of f of x. Well, let's just take the time to write it. Most of the time on my worksheets I don't, but for your benefit I will. Now let's go look at the graph of x squared minus 4, and you might already imagine that negative 4 is going to be a vertical shift down. And so what I really am expecting is that my domain is also going to equal all real numbers, and my range is going to be y such that y is greater than or equal to negative 4, but let's view it and see. Well, shazam, that's exactly what it looks like. So we had g of f of x equals x squared minus 4. My domain is going to be all real numbers. My range is going to be, well, look where we bottom out. We bottom out right there at negative 4. Y is equal to negative 4, so we got y such that y is greater than or equal to negative 4. All right, well, shazam, the composition of functions. In the fog, playing golf, f of g of x, g of f of x. It's just a wonderful day.